All right, writing quadratic functions in vertex form. We've already been familiar with standard form. In standard form is y equals ax squared plus bx plus c. And from standard form, you can solve a quadratic equation by factoring, by graphing, by the quadratic equation, the quadratic formula, or completing the square. We've done all those things, even the square root method. If it's a binomial. So we've done all that with standard form. Now let's look at vertex form. Now vertex form is y equals, if you notice this right here, y equals a parentheses x minus h parentheses squared plus k. You have to notice on the vertex form that hk is actually the vertex. hk, make sure you pay attention, it's hk. And h is the AOS written as x equals h. And then of course, remember, same as standard form, a is positive if it opens up. So, and obviously if a is negative, it opens down, the parabola opens down. So let's look at a couple examples, specifically pointing out hk, because you got to know what the vertex is. So here I have three equations written in vertex form. So let's point out what the vertex is, and of course the AOS, and if it opens up or down. So remember the formula, y equals a parentheses x minus h squared plus k. So here you can see hk. Again, notice the formula, this is minus, and so is this. So h right here is actually positive 4. And then k right here is negative 2. So the vertex is 4, negative 2. If you want to look at it this way, it's always the opposite of the sign. But again, I'm just following the formula because it says x minus h. So h in here is actually positive 4. And of course, the axis of symmetry is x equals 4. That's the axis of symmetry. So, and of course, does it open up or down? Well, you look at the A. The A is positive, so it opens up. So the next one, the vertex on this, again, it is written in vertex form. So again, the formula says x minus h. So here, h is actually negative 6. And then the k is negative 5. So that's the vertex. The axis of symmetry, again, is this right here, x equals negative 6. And then, of course, you can see that the a is negative. So this parabola will be opening down. For our next one, we have x plus 2, which means the h is negative 2, the k is positive 2, the axis of symmetry is negative 2, and of course this is a positive a, so this would be opening up. So let's actually graph one all the way from the beginning to the end. All right, so here the vertex, just by looking at this formula, this equation, it's written in vertex form, and so the x, or the h, I guess, the h is positive 2, and the k is positive 3. The axis of symmetry is x equals 2. The a happens to be negative, so it opens down. And then what I want to do is find the minimum or the maximum of this vertex, of this parabola. So since it opens down, so it's going to look like this. And so the vertex is, this vertex 2, 3 will be the highest point on there is that 3 right there. So that would be the maximum value. Again, it's the highest point on there. And of course, the y-intercept can be found if we plug in 0, 0 to the x. So here's the equation, and we're going to plug in 0 for the x. And 0 minus 2 is negative 2. Negative 2 squared is 4. And then negative 2 times 4 is negative 8. Negative 8 plus 3 is negative 5. So the y-intercept is 0, negative 5. So if I start to graph this, it's 0, negative 5, and then go to 2, 3. And remember, this is also the axis of symmetry. And then you can also just flip this one over and you have your parabola. This is your vertex, that's your AOS, and this is your y-intercept. Next topic, sort of along with vertex form, we want to write vertex form in standard form. So here I'm giving you an equation that's in vertex form, and how do I write it in standard form? Remember, standard form is ax squared plus bx plus c. And so what I want to do is basically evaluate this. So remember, this means x minus 3, x minus 3. So what I'm going to do is I'm going to just kind of work this out. I'm going to FOIL this. So I'm going to get x squared minus 3x minus 3x plus 9, which is x squared minus 6x plus 9. And then I'm going to distribute the 2. So that's 2x squared minus 12x plus 18. And then I can combine like terms. So y equals 2x squared minus 12x plus 19 is the exact same graph. And now let's look at how to write it in standard form, in vertex form. So here, if I gave you a problem, if I gave you this problem, and notice it's in standard form, so but I'm going to write it in vertex form. And I'm giving you a strong hint right here, is to use completing the square. So if I was using completing the square, here's what you kind of need to do. First, rewrite it, but kind of space that 11 out to the side, and then you kind of, in a sense, you kind of ignore it just for a little bit. And what you're going to do is just pretend that what if it was just like x squared minus 8x, equals 0, something like that, and I wanted to use completing the square. So you find that missing number, that magical number, by using b divided by 2 squared. And then b is negative 8, which is negative 4, which is 16, positive 16. So 16 is my magical number that what I'm going to do is I'm going to end up adding that to both sides of the equation. So what I have now, I have y plus 16 over here. Remember, this factors perfectly, and again, that 11 is just over to the side. This factors perfectly to x minus 4. Again, hint, hint. There it is right there. And then all you have to do is minus 16 from both sides. And you have vertex form. And that's how you would do that, is use completing the square.